Hello there and good afternoon, amazing. Today's class is actually meant for the SS1 group for the senior secondary schools. Today we're going to be learning how to balance chemical equations. So I'm super excited to have you around. This is David, the billionaire teacher who takes the mystery out of chemistry so you can make history. So let's get right into what we have for today's class, learning how to balance chemical equations. All right, so by way of introduction, I have just one thing that I want you to be able to do by the end of this class. By the time we're wrapping the curtains on this class, there are a few things that I want you to be able to do, and it can be summarized in one statement. I want you to be able to know how to balance chemical equations. Wherever you are, if you're called upon to balance a chemical equation, I want you to be able to know what to do. So let's quickly go into what this lesson is all about today. So first things first, a chemical equation is simply a sentence in chemistry. That is what a chemical equation is. A sentence that tells us what substances are reacting, what substances are formed. So for instance, let's say I represent an element with the symbol letter A, and that symbol letter A is reacting with another symbol letter B, and they produce something you call letter C. This entire statement that I have just written is what we call a chemical equation. It is showing us the things that are reacting together, which are represented by this symbol. These are the reactants, and it is showing us things that are being produced, represented by this symbol, the letter C. These are called the products. Okay, so now that we know what a chemical equation is, it is important to know how to balance them. But before we get right into that, it is also important to know the parts that make up an ideal chemical equation. So at first glance, I remember when I began to learn about balancing chemical equations, I was just looking so confused because I would see a chemical equation looking like this. For instance, let's say we have hydrogen H2 plus oxygen producing water H2O. I'd be wondering, okay, what does this two mean? This H, what is this? Why is it standing there? This O2, what is the significance? I was just absolutely confused until I learned the concept of balancing chemical equations, which is what I want to teach you today. There are different parts that make up a chemical equation, and that's what I want to show to you now. Once you know those parts, you'd be able to balance chemical equations like a piece of cake. So part number one are the parts that we call the reactants and the products. So we have the reactants. The reactants are simply the substances that you start with. They are the ones that react. A very good example is this chemical equation we have on the screen right now. We have methane, CH4, reacting with O2, oxygen. These two guys over here that are on the left side of this arrow are the ones that we call the reactants. Now, why are they called the reactants? The reactants are simply the ones that are reacting or combining together. So the things that react or combine together are the ones that are called reactants. So now that we know what the reactants are, the next part of a chemical equation is called the products. The products are the new substances that are formed after the reaction. So the products are usually located on the right-hand side of the chemical equation. So you can see two products over here, carbon dioxide, CO2, and water, H2O. So we can see the outlining over here. We have the reactants labeled oxygen and methane, and we have the products, carbon dioxide and water. So part number one are the reactants and the products. Part number two is called the coefficients and the subscripts. So let me backtrack a bit. When we have a chemical equation, for instance, let's say the equation that shows the reaction between hydrogen and oxygen to produce water. H2O. Now, the subscripts are simply the small numbers that are within a chemical formula. Let me label them all for you. You can see the small number twos that are placed in front of symbols, they are called subscripts. Now, what are they? They are simply the numbers that tell you the number of atoms of an element that is present in one molecule. For instance, over here we have a subscript of 2, and that 2 is standing in front of the symbol H, which is for hydrogen. So that is simply telling you that hydrogen has 2 atoms present on the left-hand side of the chemical equation. Same thing goes for this number 2 over here. It is standing in front of oxygen, and that is telling you that there are 2 atoms of oxygen present on the left-hand side of the chemical equation. And this number 2 over here is standing in front of hydrogen as well. It tells you that there are 2 atoms of hydrogen present on the right-hand side of the chemical equation. Now, when a chemical equation is balanced, usually it is done by the introduction of something that we call coefficients. Now, if I'm to balance this chemical equation, this is what it is going to look like. I've introduced a couple of coefficients, 2 over here and over here. Don't worry, I'm going to be showing you what it means as we progress in today's lesson. But a coefficient, let's see what it means right now. A coefficient is the big number that is placed in front of chemical formulas, which tells us the number of molecules that are present. For instance, now you can see there is a number 2 over here. So it is telling us that there are 2 molecules. Now watch this trick. Hydrogen over here has a subscript of 2, and there is a coefficient of 2 over here. What it means is that the total number of atoms of hydrogen will become 2 multiplied by 2. That gives us 4. So in order to get the total number of atoms that are present in a molecule, you multiply the subscript by the coefficient. I hope that is clear over here. So now, for example, over here we have oxygen. The subscript is not identified, so it is 1. Usually, if the subscript is not identified, it is a number 1. So how many atoms of oxygen do I have? I'll simply multiply the subscript 1 by the coefficient, which is 2. So that gives me 2 atoms of oxygen that are present. So we have seen the coefficient and the subscript. So next up on our list that we are looking at are the states of matter. Now, when chemical equations or chemical reactions take place, the substances that react do so in different states of matter. They can be in the solid state, they can be in the liquid state, they can be in the gaseous state, or they can even be in an aqueous solution. Now, this is what we mean. For instance, when you see in a chemical equation this notation, it is simply telling you that that substance is in the solid state of matter. When you see an L like this, it means it is in the liquid state of matter. When you see a G, it means it is in the gaseous state of matter. And then finally, when you see an AQ like this, it means it is in the aqueous state. Aqueous state simply means it has been dissolved in water. Aqueous was derived from the word aqua. So now that we know all this, we're prepped up to begin the process of balancing chemical equations. Now, balancing chemical equations might look scary at first. You might be feeling frazzled right now. I totally understand, okay? But once you break it down into simple steps, it becomes just like solving a puzzle. So we're going to go slowly and practically into the process of balancing chemical equations. So let's begin one step in 30 minutes time. So let's go over the steps one after the other. So step number 1, to balance the chemical equation, you need to count to track atoms. So let's say we are balancing this chemical equation, H2 plus O2 producing H2O. We're going to count to track the atoms. So first things first, let's list out the elements that we have. We have hydrogen and we have oxygen. So on the left-hand side of the chemical equation, let me rewrite it in a bolder format that you can see clearly. How many atoms of hydrogen do we have on the left-hand side? We have hydrogen over here with a subscript of 2. So on the left-hand side, we have 2 atoms of hydrogen. On the right-hand side, hydrogen is also over here with a subscript of 2. We also have 2 atoms of hydrogen. So hydrogen is balanced for now. How about oxygen? On the left-hand side, you can see oxygen having a subscript of 2, which means we have 2 atoms of oxygen. On the right-hand side, oxygen has no subscript, or the subscript is just 1. So we have 1 atom of oxygen. So oxygen is not balanced. So now that we've counted all the atoms, the second step says balance one element at a time. So the element that is not balanced in this case is oxygen. So let's balance oxygen. We have 2 on the left and we have 1 on the right. How do we balance it? We introduce a coefficient that will make the right-hand side, which is 1, to become equal to the left-hand side, which is 2. What coefficient do we introduce? I will simply multiply the smaller number by a number that will make it equal to the bigger one. So to make 1 equal to 2, I'll just simply multiply it by 2. Doing that, I will introduce the coefficient of 2 in front of this place. That way, oxygen over here now has a subscript of 1 and a coefficient of 2, which means we now have 2 atoms of oxygen on the right-hand side. That way, oxygen is now balanced both on the left and on the right. So let me rewrite the equation, what it will look like right now. I have H2 plus 2O2 giving me I beg your pardon, that was not what I was supposed to write. H2 plus O2 giving me H2O. So I have a 2 in front of H2O. Now the next thing to do is to always count my atoms after introducing a coefficient. So I've introduced the coefficient right now. Let's count the atoms to see. On the left-hand side, we have 2 atoms of hydrogen. So hydrogen on the left has 2 atoms. On the right-hand side, how many? I have hydrogen over here. It has a coefficient of 2 and a subscript of 2, which means 2 times 2, which gives 4 on the right-hand side. How about oxygen? Oxygen on the left-hand side has a subscript of 2. And on the right-hand side, you can see oxygen. Oh, it has a subscript of 1. And this coefficient of 2 here. So we have 2 times 1, which gives us 2. So 2 on the left and 2 on the right means oxygen is balanced. So the one we're going to balance now is hydrogen. 2 on the left and 4 on the right. It means that I'm going to introduce a coefficient to this 2, which is the smaller one, that will make it equal to 4. What number can I multiply by 2 that will give me 4? It is simply 2. So I'm introducing a coefficient of 2 over here to make hydrogen to become 4. That way, my equation now becomes 2H2 plus O2, giving me 2H2O. So now let's go ahead and check if all the elements are balanced. Hydrogen on the left, coefficient of 2 and subscript of 2, which means 4 atoms. On the right, you can see a coefficient of 2 and a subscript of 2, which gives us 4 atoms of hydrogen as well. Hydrogen is balanced. How about oxygen? On the left, we have 2 atoms of oxygen, and on the right, you can see this coefficient of 2, which tells us that oxygen has 2 atoms. So both hydrogen and oxygen are fully balanced. An equation is fully balanced when all the elements have the same number of atoms on the left and on the right. So let's write out our fully balanced chemical equation. We have H2 plus O2 giving us H2O. These are the coefficients that we introduced. This is our fully balanced chemical equation. So let's go ahead and solve another chemical equation. Here are more rules that we did not outline. Here, this one says start with complex molecules first. We're going to be seeing examples where that rule will apply. And then this one also says pick an element and count how many are on the left and on the right. We did that just now with this example that we just solved. So let's solve another example and see how it plays out. So we have this one over here. We have CH3 or C3H8, that's propane, plus O2 oxygen giving CO2 and H2O. So let's see what the rule says. The rule says, first of all, list out all the elements that you have. So what are the elements that you have? We have carbon, which stands for this C, and then we have hydrogen, and then we have oxygen. So let's go over the rules and do what they say. So the first step says count to track atoms. So what does it mean to count to track atoms? We'll simply pick every element and count the number of atoms that are on the left and on the right hand side. So we have carbon, which is the first one. On the left hand side, we have C3. So this subscript of 3 tells us that carbon has 3 atoms on the left. And then on the right, we have CO2. Carbon has just 1 atom. So 3 on the left and 1 on the right. How about hydrogen? You can see we have H8 on the left, which means that hydrogen has 8 atoms on the left. And then on the right, we have H2. The subscript of 2 tells us that there are 2 atoms of hydrogen on the right. And then oxygen on the left, you can see we have O2. And on the right, we have just O. So 2 on the left. Oxygen actually appears 2 times. Let's not mistake that. So we have over here O2. Let's write that out, O2. And then over here we have O. O2 and O. So 2 atoms of oxygen over here and 1 atom of oxygen over here. 2 plus 1 gives us 3. So we have 2 on the left and 3 on the right. You can see how we outlined all the elements and counted the number of atoms for each of them on both sides. On the left-hand side, we counted, and on the right-hand side, we also counted. By the way, if you're enjoying this video, I'm imploring you to please like, share with as many as you can, and subscribe for more amazing content that will be coming your way consistently. So now that we have counted the elements that are present, what is the next thing to do? Balance one element at a time. Trying to fix everything at once will confuse you. And then we'll start with the complex molecules first. So the most complex molecule we have in this chemical equation is this guy over here, C3H8. So let's start with carbon. On the left-hand side, we have 3, and on the right-hand side, we have 1. It means that the smaller between the two of them is 1, and I need to multiply 1 by something that will make it equal to 3. What can I multiply 1 by that will make it equal to 3? It is definitely the number 3. So that means I will introduce a coefficient of 3 on the right-hand side. So therefore, this equation now becomes C3H8 plus O2, giving me 3CO2 plus H2O. That is the step number 1. I've balanced carbon now with 3 atoms of carbon on the left and 3 atoms of carbon on the right. The next atom to balance is hydrogen. How many atoms of hydrogen do I have? On the left-hand side, I have H8, 8 atoms of hydrogen. On the right-hand side, how many do I have now? H2, 2 atoms of hydrogen. So to make them equal, I'll simply multiply the smaller number 2 by 4, which will make it 8. So I'll introduce a coefficient of 4 on the right-hand side. So this is how the equation now becomes C3H8 plus O2, giving us 3CO2 plus 4H2O. Did you see how that was done? That way, hydrogen is now 8 on the left and also 8 on the right. And then finally, we have oxygen. Oxygen, how many atoms of oxygen do I have on the left? You can see oxygen over here. How many atoms? It has a subscript of 2, which means there are 2 atoms of oxygen on the left. On the right-hand side, how many times does oxygen appear? You can see oxygen over here. It has a subscript of 2 and a coefficient of 3. That's 2 times 3, which gives us 6. Oxygen also appears here. You can see that. And it has a subscript of just 1 and a coefficient of 4. That's 4 atoms. So altogether, on the right-hand side, we have 6 plus 4, which gives us 10 atoms of oxygen on the right-hand side. So now I have 2 on the left and 10 on the right. It means that on the left-hand side, I would have to multiply by 5 or introduce a coefficient of 5 to make oxygen to be balanced or equal on both sides. So that way, if I put a coefficient of 5 over here, the full equation now becomes C3 H8 plus 5O2 giving 3CO2 plus 4H2O. Now, we're going to go and check if the equation is fully balanced. All the elements, how many atoms of each of them are on the left and on the right hand side. So let's go ahead and find that out right now. First things first, we're going to go with carbon. We have 3 atoms of carbon on the left and also 3 atoms of carbon on the right. Carbon is balanced. Hydrogen, we have 8 atoms of hydrogen on the left, and also over here you can see 8 atoms of hydrogen on the right. And then oxygen, we have 10 on the left. And so next up, we have this chemical equation on the screen right now. Let's go ahead and balance it. First things first, we outline all the elements that we have. We have aluminum, Al. We have hydrogen, H, and then we have chlorine, Cl. For aluminum, we have 1 atom on the left as located over here. And we also have aluminum appearing on the right over here, 1 atom on the right. And for hydrogen, over here we have hydrogen H, 1 atom on the left. And over here we have hydrogen H, 2 atoms on the right. And then finally we have chlorine. On the left, you can see chlorine here appearing just once. And then over here we have 3 atoms of chlorine on the right. So now, among the rules that we read, one of them said, make sure that you start with the most complex molecule first. Among all the molecules, the most complex of them is this guy over here. And this molecule contains aluminum and it contains chlorine, Cl. Aluminum is balanced. So we'll move to the next one that is not balanced, which is chlorine. Chlorine on the left is 1 and on the right it is 3. So it means I'll introduce a coefficient of 3 on the right, on the left, to make it balanced. That way, the equation now becomes Al plus 3HCl, giving us AlCl3 plus H2. Can you see how I introduced the coefficient? That way, chlorine has become 3 on the left and is also 3 on the right. So now the next thing I'm going to do is to count the number of atoms that I have for all elements. For aluminium, I have 1 on the left, and on the right-hand side, I still have 1. Aluminium is still balanced. For hydrogen, you can see over here, introducing a coefficient of 3 now made it to be 3 on the left. And on the right-hand side, how many atoms of hydrogen do I have? I have 2. And then chlorine, I have 3 on the left and I still have 3 on the right. So the next element to balance will now be hydrogen. 3 on the left and 2 on the right means I will have to multiply in such a way that the two of them becomes equal. So how do I do that? Now, there is no whole number that I can use to multiply either 2 or 3 to make them equal to each other. So I'm just simply going to multiply this 3 here by this 2 and multiply this 2 here by this 3 so that I can have 6 atoms on both sides. So how am I going to do that? It is hydrogen that I want to balance. I have just 2 atoms over here. So I'll introduce a coefficient of 3 to make the number of atoms of hydrogen on the right-hand side to be 6. And over here, I'll change the coefficient to become 6. That way, I now have 6 atoms of hydrogen on both sides. So now let's go ahead and check if all the atoms are balanced. I have 1 atom of aluminum here and 1 over here. Next up, I have 6 atoms of hydrogen over here and also 6 over here. And then for chlorine, how many atoms of chlorine do I have? On the left-hand side, I have 6 atoms of chlorine because of this coefficient. And on the right-hand side, I have 3. So that means I'll have to introduce a coefficient of 2 over here to make chlorine now to become 6 atoms. And since I've introduced the coefficient of 2 to make aluminium to become 2 atoms now, I'll also introduce a coefficient of 2 over here. So now let me write out the full equation to show how it will look. I have 2 atoms of aluminium plus 6HCl, giving 2AlCl3 plus 3H2. If we count the number of atoms for each element on both sides, they will be balanced. For aluminium, 2 on both sides, for hydrogen, 6 on both sides, and for chlorine, 6 on both sides. So that's how you balance this kind of chemical equation. So here are some assignments that I want you to carry out by yourself. I want you to do this one and also these ones that are listed out on the screen. So we've come to the end for today's lesson. I look forward to seeing you in more live classes where we get to deal with more intriguing subjects one-on-one. Thank you. It's been David, the billionaire teacher, and I look forward to seeing you in more of my lessons. Bye-bye for now.